Ideas for success are presented through this video to the teaching community. Science is a subject of great fascination to children, and developing science skills are imperative. Let me now walk you down the list of science skills that should be developed in children. To begin with, let me invite you to watch, share, and subscribe to this channel to get more ideas and become a celebrated teacher. Also, if you have great ideas, you can share them with me using the details available in the description box. Now let's watch the skills and sub-skills of science. Expectedly, it's observing first, followed by measuring, data handling, experimenting, thinking, applying, hypothesizing, math skills, and presentation. Let me elaborate the primary skill in learning science, which is observing. Observation focuses on what and how of things and not on the why. Children can use various senses to obtain information. It is a continuous process and can be qualitative or quantitative. Children should be taught what and how to observe and also record their observations without bias. For qualitative observations, activities like looking at the position of sun at different times during the day, feeling the hotness or coldness of water, smelling the perfume from another room, hearing the sounds made by different birds, and tasting a lemonade allow learners to use various senses to observe. Next comes measurement, which is a skill that quantifies observation. It includes measuring distance, weight, volume, angle, temperature, time, and any other physical quantity related to the system. It can be accomplished by direct or indirect comparison against a standard. Children should be given opportunities to measure their observations. It is to help them to be precise with their observations. Activities like measuring the length of the desk, time taken to reach school, momentum of a moving ball, volume of water consumed in a day can be easily done by children. They can also compare their results with their peers and learn more. Next on list is the experimenting skill, which is being able to conduct an experiment, knowing the objectives, state a hypothesis, identify and control variables, operationally define those variables based upon the observable characteristics of the phenomena and the operations to be performed, design the experiment, perform the experiment, record the data or observations, interpret the results, and recognize experimental errors. Experiments can be conducted for almost all the concepts that children learn at school. Simple experiments like study on the effect of organic matter on the growth of plants, shadows formed by an object at different angles of light source, producing natural dyes from different vegetables or fruits, and so on. Next is data handling, which includes recording the experimental values, studying the values, extrapolating if necessary, choosing the right set of values for analysis, analyzing the data, interpreting the data, and draw conclusions. An example activity is recording plant growth data and concluding the relationship between data and other variables. Children can be encouraged to collect data on various topics or concepts they learn. A very essential skill is thinking. It's an universal skill required to master all the subjects, more so with science. Thinking is the process that enables us to make informed choices. Thinking skills refer to the knowing how and include creative thinking, higher order thinking, critical thinking, creative thinking, metacognition, problem solving, and scientific reasoning. Scientific reasoning or scientific thinking refers to the application of the methods of scientific inquiry to reasoning or problem solving. Questioning is part of thinking. Questions are formed on the basis of observations made. Questions, in turn, will become problems to be solved using other skills of science. Questioning skills are abilities that allow to analyze processes, concepts, or situations and ask relevant and purposeful questions. Commonly, the WH technique can be used, which involves the 5 Whys: who, what, where, when, and why, and 1 H, how. This questioning technique is simple, but the extent of 5W questions is usually close-ended. Hence, teachers can easily use Bloom's taxonomy ideas to ask questions at an advanced level. Thinking includes classification, which is based on the characteristics, behavior, and interrelationships in the group of objects or events that are observed. Schemes are created based on the similarities and differences. Inferring, another skill related to thinking, is to draw conclusions logically from what we observe. It refers to our understanding of an event and our perception based on the evidences and experiences. Predicting is another thinking skill, which is the formulation of a future behavior based on previous experience. Predictions are based on observations, measurements, analysis, and inferences that we make about the relationships between different variables. Simple tasks can be given to learners, like predicting if a plant can grow in a particular place, if the container can hold a certain volume of a liquid, if light will be reflected from a particular surface, and so on. Building thinking skills can be achieved through interactions, open-ended questions, doing experiments, and solving problems. To develop thinking, children can be asked to give examples and non-examples, observe and present a different point of view, suggest an alternate explanation, ask questions, and read more. Tasks like observing how things falling down experience a natural force to attract objects towards the earth, why plants and trees yield fruits at a certain time, how geographical location affects the weather pattern, how the age of the tree can be calculated from the tree rings, and so on. A very crucial ability is the skill of applying, because science is a subject to be applied in life. Learners should be guided to apply the principles, theories, rules, laws, methods, standards, conventions, ideas, procedures, and postulates to new situations. Students should apply an abstract idea to a concrete situation to solve a problem. Activities like constructing a model to demonstrate how something will work, solving problems, can be regularly used in the classroom. The next skill, formulating hypothesis, is to state the expected outcome of an experiment. It is an idea or proposition that can be tested by observations or experiments about the natural world. Hypotheses can be simple or complex. Some examples are: if you drop an object, it will fall downwards. If greater amount of soil nutrients are available, greater will be the plant growth. If children have proper diet, they will not fall ill but perform better. The best one of all is the mathematical skills, which are quite crucial in learning science. It includes the skill of using numbers, using significant numbers, giving values to quantities, expressing quantities in standard units, conversion of units, doing calculations, developing equations for the system, interpreting equations, plotting graphs, interpreting graphs, manipulating numbers, connecting quantities, proportional reasoning, spatial skills, and using space-time relationship. Since science deals with nature, everything happens around time. Visualizing and realizing this has to be developed to understand various processes. It also includes estimation, which is the process of finding an approximate value which will be usable even if the data available may not be precise. Estimation helps to identify errors and also check the result. Tasks for developing each of these can be designed appropriate to the topic and level. Next is formulating models, which refer to constructing a scientific model which can be physical, mathematical, or conceptual representation of a system of ideas, events, or processes. Usually, scientists identify and understand patterns in our world by using their scientific knowledge and offer explanations that enable the patterns to be predicted. Some examples are climate change model, city planning model, and the model of how the processes of evaporation and condensation interrelate in the water cycle. Finally, it's presentation, which is to present newfound ideas to the scientific community and the world. Presentation can be written, printed, oral, or through any media. Presentation must be informative and error-free. In science, presentation should include data, table, chart, graph, equations, diagrams, or models. Different modes and media of presentation can be included. Children have to be trained and given opportunities to present their ideas and findings to their peers. One can truly sell an idea through good presentation. Hope this video helps you to understand the various skills in learning science. Now get ready to develop these skills in every child in your classroom and make them future scientists. Wishing you and your students great success.